This video will cover the second part of the lecture on anatomy of Earth and plate tectonics. The learning outcomes are same as the previous lecture. Firstly, to understand the structures of Earth, how the dynamic of Earth affected the surface expression and interaction of plate boundaries and Earth dynamics. Plate boundaries are defined as places where the two plates meet. The interactions at the boundary involve important geological processes such as mountain building, earthquake, volcanism, basin formation or opening. Depends on the relative movement of the plate. They can be divided into convergent, divergent and transform boundaries. This illustration shows the all three types of interactions of plate boundaries. Divergent plate boundaries created gap on the surface, convergent plate boundaries created the overlapping, and the transform plate boundaries have a sliding motion. This illustration of different plate boundaries by geological symbols. Divergent plate boundaries are represented by the two arrows pointing in opposite direction. Convergent plate boundary can be represented by transform symbol or line with the tooth. Transcurrent or transform plate boundaries are represented by dextral or sinistral symbol. The lithosphere has been divided into 16 large or major plates and another 24 smaller or minor plates. The white line on the top of plate boundaries and their motions or movement. The drifting rate of plates are commonly between 5 to 10 cm per year. The map shows the velocity and directions of movement at plate boundaries. Blue line are convergent plate boundaries. Red line are divergent plate boundaries. Lengths and the arrows. Lengths of the arrows are proportional to the velocity of plate movement. The numbers represented the velocity in centimeter per year. Constructive or divergent plate boundaries refer to plate move away from one another at their boundaries and new lithosphere created. The example are mid-oceanic ridge and the rifting zone. One of the example of constructive plate boundaries is Red Sea, which is situated between Egypt and Saudi Arabia. The new lithosphere is formed at the mid-oceanic ridge of Red Sea. The old plate have been pushed away. The oceanic crust is generated at constructive plate boundaries, which made of ophiolites. The main lithologies of the ophiolites are periodite, gabbro, basaltic dike, pillow basalt, and deep sea sediment. Convergence occur at a destructive plate boundaries. The convergence can be happen as oceanic crust subducted underneath continental crust, oceanic crust subducted underneath oceanic crust, and continental crust collide or subducted underneath continental crust. Destructive plate boundaries are the places where the lithosphere consumed. The three cases mentioned before are shown here. In first case, the Nazca plate or oceanic crust subducted underneath South American plate, which is the continental crust. Second case, the oceanic crust subducted another oceanic crust. You can observe at Japan Trench, where Pacific plate subducted underneath the Eurasian plate. Third case is a continental to continental collision, which can be seen at the Himalayas area, where the Indian Australian plate collide with the Eurasian plate. Two major events occur at the destructive plate boundaries as mentioned before, which are subduction and collision. At subduction zone, one plate sink or subduct underneath another plate into mantle. The subduction plate is an oceanic plate, while the overriding plate can be either oceanic or continental. At collision zone, both plates are continental. In the final phase of subduction, when all the oceanic plates are consumed, the collision will occur. Converging plate boundaries are marked in the either deep trenches or highly folded mountain belt. The trench is formed due to oceanic lithosphere converge and one descends into mantle. Both earthquakes and volcanic activities are common at convergent plate boundaries due to the plate movement. The opposite plane motions are marked in the map as arrow, which is where the arrow length is proportional to the velocity. The trench and mountain beds are also marked in the map. This illustration shows how the Indian collided with the Eurasian plate. At the beginning, the oceanic crust between India and Eurasia are consumed at trench. After all the oceanic crust are consumed, the India's continental crust is collided with Eurasia continental crust and form the mountain belt. The collisions between India and Eurasia created faults, mountains, plateaus as shown in the map. It also affected the region at the east, such as China and Southeast Asia, which drove part of Southeast Asia and China eastward along lengthy slip fault or shear zone. The blue lines are the major faults. The arrow mark the motions of the plate. Transform plate boundaries is referred to the motion of two plates is parallel to their boundary. Lithosphere is neither created nor deformed. Seismic activity is common at these plate boundaries. Strain is often concentrated at plate boundaries. The typical example of transform plate boundaries is San Andreas Fault in California. Based on the relative movement along the fracture zone or transform fault, we can classify them into inactive and active fracture zone. The active fracture zone occur at the area lies between two ridge segments where the plates on opposite sides of the fault move in the opposite direction. Beyond the spreading ridge, the plates move in the same direction on both sides of the fault is called inactive fracture zone. Now we know that plates fit together and cover over the mantle and core of Earth. The questions raised up new era: what made up the plate and what force drive the plate to move? Mantle convection is playing the major role in plate tectonics. The cold oceanic plates act as the upper thermal boundary of the convection, where the mantle is powered or heated by radiogenic heating and slow cooling of the planet over 4.5 billion years. Due to temperature difference, the heat will transfer from deeper mantle to shallower crust and create the convection. And the lithosphere asthenosphere boundary or LAB is also respond to this mantle convection. When the LAB move up, the lithosphere extends or stretch. LAB move down, and during the lithosphere is shortened and to return back later at thermal relaxation stage. The illustration in this slide shows the mantle convection, which the convection cell either big or small push the mantle matrix upward and form the new lithosphere and push the old plate apart. The relatively lower viscosity of mantle also help the mantle matrix beneath lithosphere to move. Several mechanisms acted as the driving force of plate movement. They are ridge push, slant pull, and mantle drag. Slack pull and mantle drag, which also related to mantle convection. Ridge push is referred to the rise of hotter mantle material below an ocean ridge produce a large low density barge which exert a lateral gravitational pressure on the plates or either side. Slack pull is occurred when the gravitational effect of cooler, denser material in and around the sinking slab at trench during subduction. Mantle drag occurred when the lateral convection flow within the atmosphere beneath the lithosphere and effectively pulls the plates along. As the conclusion of this lecture, the main plate boundaries are convergent, divergent, and transform. These boundaries are commonly marked location and explain occurrence of volcanic and earthquake activity, as well as basin formation. Plate movement is closely related to mantle convection, and the main mechanism are ridge push, slab pull, and mantle drag.